Another quick little annuities video here. We've got one other formula. So this one is if we want to find the present value. So what this one might be, and again it works very similar to the other one, just a different situation. If I am putting in this much money now, and let's suppose my son is going off to university, I want to figure out how much money I need to put into the bank now so that he can take out um, 50 bucks a month for food. Suppose I said I would pay 50 bucks a month to him for food. So I would need to put in less money now, because if I put in then, sorry, I would need to put in less money now than if he's going to be in school for 1 year and he's going to take out 50 bucks a month. It would be less than 50 times 12 because I'm getting interest with all that money in there, but it gets a little bit less. So I get lots of interest on the full amount for the first month, but then he takes out 50 bucks. So I get a little bit less on the next one. So that's what's happening in this one, is you're putting in a bunch, and then again, our or withdrawal, this one would be, is the regular payment out. I is our compounding period, N again is this one is the number of payments or withdrawals. Like the last one, I would say it is for the compounding period. So let's look at a couple here. So Roshan has set up an annuity to help his son pay living expenses over the next 5 years. The annuity will pay $50 a month. Oh, this is almost exactly like what I said. The first payment will be made 1 month from now. The annuity earns 7.75% compounded monthly. Okay, so I'll call them all up and we'll say where we got them from. So this one, we're trying to figure out how much money do you need to put in now in order to have that happen. So we've got the percentage. Now it says compounded monthly. That is a number, remember? So we got to take our 7.75, move the decimal place 2 spots. That's where the 0.075 came from. Divide that one by 12. Okay? Now for our N, it's going to be in there for 5 years, compounded monthly, so times 12. Okay? Now our R is how much is coming out. That's our payment. So we're taking out 50 bucks. All we got to do, we get this formula, remember, is pull those numbers out of the description of what's happening, sub it into our formula. Now you could probably round 0.006, especially if it's a multiple choice question, you'll get one close. But the more you round, the more it changes, especially in things like trig and dealing with money with exponential stuff. They do such a jump right there because they're probably using one of the TI-83s. They can just type it into their calculator looking like that and they jump down to the answer. If we need a couple more lines in there, remember, do the brackets and the exponents, brackets, exponents, division, multiplication, addition, subtraction, and we should break down to that. I find the trickiest part of these questions, though, is figuring out the values. Once you sub in, it's just some old algebra that we've been doing. Oh, okay, so if we look at this, oh, hang on, I'm going all over the place. If you're taking it out for 5 years every month, you should have $3,000, right? And so what I was saying, our answer from the last one was 2,480. You don't have to put the full amount in at the beginning. You can put less money in at the beginning because you're getting interest. So they're getting almost 520 bucks of free money by putting that 2,480.53 in at the beginning and letting Roshan take out that 50 bucks per month. So anyways, hopefully that helps. Here is one more example with it. Somebody bought a bicycle for 15,000, or sorry, 1,500. She arranged 15,000. That would have been a pretty good bike. Maybe it would have been a motorbike. But anyways, 1,500. Maybe it's an e-bike. Robin bought it. She arranged to make a payment to the store at the end of every month for 1 year. The store is charging 11% interest compounded monthly. Remember, the compounded monthly is key. That means we're going to have to divide by 12 times by 12 here. So the amount is that. Now, it looks like in this one, we don't know what the payment is going to be. So that's why our R is missing here. So we're going to have to sub in and kind of rearrange a little bit. Our I, right? I don't really like how that's written. The percent should be up on the top there, so it should be 0.11, 0.11 divided by 12. That looks a little bit weird how it's written. Because we're dividing by 12 because it's compounded monthly. And then down here, it's just 12 because for 1 year, monthly payments, so 12. Okay, so that's how we get all those values. The trickiest part is getting the values. Next, it's just subbing it in, right? You put the I where the I, the N where the N, everything like that. Now we're solving. So again, this is doing it all in one step. They're multiplying up, and then they're dividing that big thing. You could work it out and work out each of the brackets and do the multiplication step by step if you wanted to. And then there it gives us what the monthly payment for that situation would be. Anyways, if you have questions, please don't hesitate to post in the discussion. You can try some and we'll see how we do on this stuff.